So today we're talking 5.3, day 1, trigonomic functions of any angle. Why any angle? Because so far, you've only been doing trigonomic functions of acute angles. Why acute angles? Because all we've done so far is right triangle trig. Well, in a right triangle, your two corners are acute corners. So if you can think about placing a right triangle into standard form, your right triangle is always going to lie right here in quadrant 1. Okay? So now we're going to talk about finding with sine and cosine and tangent for obtuse angles, angles that lie in quadrant 2. Remember, we named the angle by where its terminal side lies. So here, this line, this terminal side, is in quadrant 2, so we say that theta lies in quadrant 2. So here we have an angle that's somewhere between 90 and 180 degrees. How do I do my 6 trig functions on an angle that's greater than 90 degrees? Well, here's where these ratios are going to come in. So what does all of this mean? Let's go back to that original one. And when we do this sine is opposite over hypotenuse, right? So if you can picture this triangle, well, your opposite is here. Well, the height of your triangle is the y value of this point up here at the top. And then your hypotenuse just so happens to be what we call the radius right here. Why do we call it the radius? Because we're doing this under the guise that this point right here that we're working on, this xy point right here, that point came plucked out of a circle. So we're going to talk about this now as instead of right triangle trig, we're going to talk about it as circle trig. So here we have the r for the radius is basically our hypotenuse now. Okay? So we can extend that now into all of the other different functions. So the first thing I want you guys to write down right here is that to find the radius, it's x squared plus y squared. That's a spin-off of your distance formula, change in x squared plus change in y squared. Well, if we're starting at the origin, okay, you can see here all of these start at the origin because that puts them in standard form. Your distance is just x. Your y distance is just y. Okay? So it's going to be r equals the square root of x squared plus y squared.
How does this connect to right angle trigonometry?
Well, the way this connects to the right triangle trigonometry is now we're going to take that right triangle trigonometry and we're going to expand it. But we're going to use that right triangle trigonometry as our jump-off point. So we're going to take this thing that we already know and we're going to make it bigger. Okay? So, looking at what we have here, to find the sine is the y value over the radius. The cosine is the x value over the radius. The tangent is the y value over the x value, but x can't equal 0. All right, well, let's talk about that for a second, because that's a really important piece of information. If you think about an xy axis, so let's pretend this is our xy axis, okay? When we think about xy axes, where are x values equal to 0? At the origin is one point, but where else? What represents all points with an x value of 0? Which axis? The y-axis. On the y-axis, all x values are 0. All right, well now let's extend this into what we've done with our unit circle. So now we're basically taking our right triangle trigonometry and our unit circle and squishing it into one little sandwich. What angle degree represents that point up on the x-axis, on the y-axis, I'm sorry? That's 90 degrees. And what degree represents this one down here, 270. All right, so if that's where x equals 0, what do you think the tangent of 90 degrees is going to be? What happens when, what is x? At 90 degrees, x is 0. There is none, because you can't divide by 0. We call it undefined. Perfect. Okay? Now when we look at the reciprocal functions, all right, again, it's just like we've always had. We just reciprocate, except now we have to extend into y can't equal 0. Well, why can't y equal 0? Because it's in the denominator. But where do we find y equals 0?
On the x-axis.
On the x-axis. All right, so what degree measures do we find on our x-axis? Okay, so this one's 180. This one's 360, but it's also 0. Good, okay? So the cotangent of 360 is undefined. But what's the tangent of 360? It's 0, because y is 0. 0 divided by anything. Tangent of 360 is 0.
Are you using the points on the graph to get x and y? Or are you using like 360?
Mia, can we agree that on the x-axis, every single ordered pair here has a y value of 0? Okay. So if we take our unit circle and our coordinate plane and we put them one on top of the other so we can talk about these as x, y values, at 360 degrees, it doesn't matter how far the angle extends. Okay? A point out here is still going to be a 360 degree rotation around the origin. So remember, tangent is a ratio of the opposite over the adjacent. So we've looked at pictures where even though the opposite and adjacent measurements were different from triangle to triangle, when you set them up as a ratio, the ratio reduced to the same value. Okay? So here, just as a general rule, the tangent of 360 is 0. Okay? Other questions? All right, get these 6 ratios with their restrictions written down, please. So let's use this. So here we have a point at 1, -3, and it's on the terminal side of my angle theta. So the first thing that we're going to do is we're going to sketch a little xy axis, and we're going to plot that point in. It doesn't have to be a very precise measurement. Estimates are awesome. So the point 1, -3 lies in which quadrant? Quadrant 4. So we're going to say that it's about there. All right, so now let's look at how that would be on the terminal side of an angle theta. Okay, so here we see theta. We have some angle that's between 270 and 360 degrees. Okay? So we still have this point here at 1, -3. So what we need to do is the first thing we need to do is find our radius. So how do we find our radius? Good. X squared plus y squared square rooted. Well, here my x squared would be 1 squared. Y squared is 3 squared. That gives me the square root of 10. Can I reduce the square root of 10?
Yeah.
Absolutely not. There's no perfect square factors of 10. All right, so now I have my r value, I have my x value, and I have my y value. So now I can start finding my 6 trig functions. So we're going to start with sine. Sine of theta. What is my ratio for sine of theta?
Y over R.
Perfect, y over r. So my y value is -3. My r value is the square root of 10. Good answer? No, absolutely not. It's a terrible answer. We have to rationalize the denominator, so that makes it -3 square roots of 10 over 10. Perfect. Questions?
If they don't give you a specific point, but just give you like the graph, you can just pick any point on the line.
Okay. They're never going to give you too little information. They're always either going to give you a point, or we're going to look at one in a little bit where they give you one of the ratios. So I might tell you, okay, sine equals 2/3. Well, if sine equals 2/3, then that means the 2 is your y value. The r is 3. And then you can use this formula up top, r equals the square root of x squared plus y squared, to rearrange it to solve for x. So I'm always going to give you enough information. You're never going to have to guess. But that is a good question. Does it matter which point on this line I choose? Absolutely not. The line is the line. So wherever the line is theta. So it doesn't matter where on this line I choose a point. Angle theta is angle theta. Okay? It's going to have the exact same value. All right, so now cosine of theta. What's my ratio for cosine of theta? X over r. All right, well here my x value is 1. And my r is the square root of 10. Again, that's a terrible answer. Square root of 10 over 10. And then the last of the big three is tangent. Tangent theta is y over x. Think about your quotient ratio from over there. The quotient says tangent is sine over cosine. You only ever need to memorize how to do a sine and how to do a cosine, because once you have your sine and your cosine, you take your sine y over your cosine x. So that's why the tangent ratio is y over x. And that's a really important fact to keep in mind because it simplifies so many things. Okay, so tangent of theta is y over x. So we have -3 over 1, which is just -3. So now, before we find the other three, the cosecant, secant, and cotangent, what I want you guys to think about is sine theta, cosine theta, tangent theta. Are they talking about different angles or the same angle? They're talking about the same angle. So if I do inverse sine on -3 divided by the square root of 10, because your calculator is okay with square roots in the denominator, it fixes it for you. So if I put inverse sine of -3 over the square root of 10, and then I put inverse cosine of 1 over the square root of 10, and then I do inverse tangent of -3, what do you think is going to happen? They should give you the same answer. So this is what you're going to do to double check your work to make sure you did it right. Now I want you to see what happens as we go through these three values. So I want everybody to put into their calculator, make sure we're all in degrees, and then we're going to round to the nearest degree. What is the inverse sine of -3 divided by the square root of 10? Sine to the -1, it's this one. Which is not sine to the -1, it's inverse of sine.
Wait, I thought we only do that when we're trying to find like the acute angle. Oh wait, we're finding angles.
But now we're finding all angles, not just acute angles, so we can use this.
It's 71.565.
So your sine is going to tell you that theta is about negative 72 degrees. So they didn't give you theta, they gave you theta's coterminal angle. Now, do it on cosine. Do inverse cosine of 1 over the square root of 10. You're going to get positive 72. And we're going to talk about y in the next screen. All right, tangent. Do inverse tangent of negative 3. And again, you should get negative 72. Okay? So now, why was the cosine positive? That's weird. All right, well, we're going to get to that. So now, let's do our other ones. What is the reciprocal function for sine? What's the reciprocal function, though? I know how to reciprocate. Yes, we're going to reciprocate it. Yes, it's going to be the square root of 10 over negative 3. But which one of my trig functions is that? Cosecant. So the reciprocal function for sine is cosecant. What's the reciprocal function for cosine? Secant. Perfect. And so secant theta, we come right here, it's just the square root of 10. And then cotangent theta is the reciprocal function for tangent. So it's going to be negative 1/3. Questions? All right, let's move on. All right, so now what happens when we have the quadrantal angles? We already talked about that a little bit when we talked about the tangent and the cotangent of the 360 and the 90 and the 180. Okay, so here, again, the only big ones that you have to memorize are sine and cosine, because how do you get tangent? Tangent is sine over cosine. So the tangent of 0 degrees, aka the tangent of 360 degrees, aka the tangent of 2 pi radians, is sine over cosine. So your tangent is 0. Here at 90 degrees, or pi over 2 radians, sine is 1, cosine is 0, so tangent's undefined. Here at 180 degrees, aka pi, your sine is 0, your cosine is negative 1, and therefore your tangent 0. Same thing here at 270, aka 3 pi over 2 radians. Sine is 1, cosine 0, sine over cosine is undefined. So now think about the reciprocal functions. If tangent of 0, or 360, is 0, so if the tangent of 360 is 0, what's the cotangent of 360? What happens when it's undefined? When you reciprocate 0, you get an undefined answer. Good. All right, so now we're going to take theta equals 0 degrees. So I'm going to hand you an angle, and I'm going to say, okay, guys, here's your angle. Your angle has 0 degrees in it. What is the sine of 0 degrees? Is 0, always. Doesn't matter how big the angle is. What is the cotangent of 0 degrees? No, the tangent of 0 is 0. The cotangent is undefined. All right, theta equals pi. I hand you an angle. It has pi radians in it, aka 180 degrees. So what is the sine of an angle of pi radians? Okay. What about the cotangent of pi radians? Is again going to be undefined. From the table. It's the reciprocal of tangent. So how do you reciprocate 0 over 1? It's 1 over 0. And 1 over 0 is undefined.
Okay, but where is just pi?
Pi is 180 degrees. So the sine of pi gives you the same answer as the sine of 180 degrees. Are we good?
Yes.
Do you want to say how much time?
How many more slides are there?
3.
All right, so assuming that the theta that I give you is not a quadrantal angle, it lies in a quadrant, the sign of your trig functions depends on what quadrant it is. And so this is why when we were talking about that 1, -3, 2 of our 3 functions were negative, and 1 of them was positive, because in quadrant 1, all functions are positive. So if you have angle theta, and angle theta's terminal side lies in quadrant 1. If you do sine, cosine, tangent, cotangent, cosecant, secant, your answer is going to be positive. If your terminal side lies in quadrant 2, the only one that's going to be positive is sine, and then of course it's reciprocal cosecant. If your terminal side lies in quadrant 3, only the tangent will be positive, the cosine and sine will be negative. Well, of course, along with tangent comes cotangent. And then in quadrant 4, your cosine will be positive, but your sine and tangent will be negative. And of course, you guys know with cosine comes secant. So how in the world are you supposed to remember that? Guys, I want you to remember something about yourselves. You are a smart trig class. Because I love you.
There's a need for you weren't doing that, so we would learn something. It's an acronym.
So A, they are all positive. S, the sign is positive. T, the tan is positive. C, the cosine is positive. Okay? So if you always remember that you guys are a smart trig class, you'll always know what value to assign your trig functions. Okay? All right, so now name the quadrant in which theta lies if my theta's cotangent is positive, but the sine is negative. All right, well, because the sine is negative, which quadrant's out?
The top one.
Quadrant 1. Okay, so where, other than quadrant 1, is my cotangent positive? Quadrant 3. So wherever theta is, it lies in quadrant 3. Remember, a smart trig tangent. All right, so now I'm going to tell you that cotangent is negative. So we have a new one. The cotangent of beta is negative 4/3. So cotangent's negative. That means it's not quadrant 1. And the sine is positive. So in which quadrant is sine positive? In quadrant 2. So my angle lies in quadrant 2. Now what do you know about xy points in quadrant 2? The x's are negative and the y's are positive. So here when we have cotangent of beta, equals negative 4/3. What is the ratio for cotangent? From like 3 slides ago. So that means x is negative 4 and y is 3. If it had been in a different quadrant, I would have taken that negative sign and put it with the y maybe. Okay, so that's why knowing what your signs are in your quadrants is very important. So now that I have my cotangent, which means that I have my x and my y, I can now find my r, because you need r to find sine and cosine. So there's the square root of x squared plus y squared. And in this case, what's the value of my r? 5. So what's my ratio for sine? Sine is? What's my ratio? It's y over r. So my y is 3, my r is 5. So what's the reciprocal of my sine function?
Don't copy.
Okay, r over y is going to be the value of the function. What is the function that is the reciprocal of the sine? Cosecant. So your cosecant is then 5/3. All right, your cosine of beta. Cosine's ratio is
R,
x over r.
which is -4 over 5.
What is the reciprocal ratio, reciprocal function, I'm sorry, what is the reciprocal function for cosine? Secant. So it means secant is -5 over 4. Now, what's the only one we haven't done yet?
Tangent.
We haven't done tangent. And tangent is the reciprocal, tangent is reciprocal to which function? Cotangent. What's cotangent? -4/3. So what's tangent? -3/4. Memorize, memorize, memorize. Are there any other, bless you, are there any other questions? Your homework tonight is page 525, numbers 2 through 34 even. 1, show all your work. 2, if you wait until Thursday night or Friday morning to study for the quiz on Friday, you're going to fail the quiz. Because you shouldn't be waiting till the night before. Because some of the things that you guys had questions on show me that you are not reviewing previous material. You need to keep current with even the previous material. So, for example, tonight when you do your 5-3 homework, you should also look over 5-1, 5-2. Next week, when you do your 5-4 homework, you should also be looking over 5-1, 5-2, and 5-3 in preparation for your test. It's the only way to make sure that you have all of this stuff memorized, because none of it's big. None of it's really hard individually. We haven't done any one individual topic that's been really hard. We've just done a ton of different individual topics. So it is a lot to memorize, and it is a lot to keep straight. So it's something that you guys are going to have to be really dedicated towards doing.